So now that you need that type, right, that custom error type, we can start talking about something called type as context. That's going to be the idea here. Suddenly the error variables are no longer working for us. There's not enough context in them. And now we need our own custom error type. Again, we're going to validate that that is the case. Let's take a look at some ideas around this type as context. And I'm going to take some types out of the standard library, because there are a couple of packages, more than one, that use custom error types when the default error type isn't giving us enough context. So here on line 16, what we see is the unmarshaled type error. This is coming out of the JSON package. And the unmarshaled type error is a concrete type that's used when you have a marshalling situation where, you said the field is a string, and maybe in the JSON it comes over as an int. We're going to have that type mismatch. You're going to get an error of this type. I want you to look at the implementation of the error interface on line 22. We're using that pointer semantics again. I want to constantly show you how pointer semantics really is kind of the default semantic for these custom error types. And we can see now, because of line 22, unmarshaled type error can be used as an error value. And I want you to look at the implementation of the error interface on line 23. One of the things I want you to check with a custom error type is that the implementation of the error method is using all of the fields in the type. If they're not using all of the fields to log something, I would question the field's necessity to provide context. Now here on line 28 is a second concrete type from the same JSON package. It's called invalid unmarshal error. And even though it's got one field, look at the implementation. There's a lot going on there, right? The message can change quite a bit depending on a few things. You're going to get an error of this type if you forget to pass the address of something into unmarshal. Remember, we talked about unmarshaling requiring those pointer semantics. So I've got two different concrete types. They're error types. I mean, look at the naming convention on these types. Your variables started with ERR, but these types end with the word error. That's our idiomatic way in Go to define that custom error type. Unmarshaled type error, invalid unmarshal error, right? So I've got these two concrete types now. I want you to look at the function on line 68. It's called unmarshal. I've taken a little bit of code out of the JSON package here for the unmarshal function. Notice that the unmarshal function asks for a slice of bytes. That's how it's asking for that string, because a string is a slice of bytes. And then it's saying, I'll accept any piece of data, any value, any pointer, regardless of the behavior. That's what the empty interface is. The empty interface is kind of a dangerous type because it tells us nothing about the concrete data that's being passed in. Got to be very careful when we use the empty interface because it tells us nothing. In this case, it's not about what it does because we don't know what it does, right? It's a very generic. And if you're using the empty interface to move data around your program, be very sure that you're doing it because at compile time, it's not about what it is or what it does. It's going to be at runtime. And that's where reflection comes in. And that's exactly what we're doing here. We want to be able to unmarshal into any piece of data and then use the reflect package to be able to do that work at runtime. But notice right here on line 70, we're asking, is the concrete value stored inside of V, right? The reflect value of starts our journey down that reflection. We're asking if that concrete data is a pointer or not. Is it nil or not? And if it is not nil, right? If it's not a pointer type or it's nil, we're going to return a concrete value of invalid unmarshal error, and the address of one. And if it's not any of that, then the error is going to be an address of that type. And what's interesting here is that what we care about in terms of error handling now is the type of value that's being stored inside the error interface that's being returned here, right? So in this case, when we get back that error variable, the concrete value is going to either be an address of this type or an address of that type, and that's what we have to do our conditional logic on. So Go, again, has a special way of doing this type as context type of conditional logic, and it's with the switch right here. So look what we do. We call unmarshal. We get back that error variable, or the interface, error interface value. We say, is there a concrete value stored inside of ERR? And if there is, now what we do is that generic type assertion. And then we ask, if we type assert to be an address of the unmarshaled type error, is that what E is going to be? And if so, then we're going to execute that logic. Or is E going to end up being the address of an invalid unmarshaled error? And if it is, E will be that, and then we'll execute that case. So the whole idea here is that our conditional logic is not based on the value itself. It's based on what type of value was stored inside of that error interface. Type as context. Now, this is cool, and there's a lot of practical uses of this type as context, not just for error handling, but for other things. But I always want to be very aware of the potential danger for type as context, because remember, the whole idea of error handling here was to maintain the decoupled state using the error interface. The more decoupled we can maintain ourselves in terms of error handling, the more change that we can apply to our code without it being cascading, right? And here suddenly, when we're talking about type as context, what's happening? We're moving from a decoupled state right back to that coupled state. We're moving from the interface back to the concrete data, which now means that if the concrete data changes, all of this error handling code changes and breaks with it. So even though I love type as context, I tend to want to avoid it when it comes to error handling. I'd rather maintain that decoupled state. I'd rather work off of the interface than off the concrete values when it comes to error handling. And there is a way to do that in Go.